Hello everyone, so in this video, let us talk about the first three problems from the Codeforces round 918. So let's start. The first problem is odd one out. As you can see, you are given three digits A, B, and C. Two of them are equal, but the third one is different from the other two. You just have to find out the one that is occurs exactly once. Now, as you can see here, A, B, and C are from 0 to 9 because they are digits. There are multiple approaches. The very simple one is that you can take every element. Let's say I'll take the first one. Let's change the color. Let's say I'll take the first one and check that whether it appears again in the array. So you can put this inside some array and check that whether it appears again. So let's say take the first element, check it with the next two. Take second element, check it with the these two. Take this element, check with this two. And if the element occurs only one time, the answer is that whatever elements you have to print, else so you just have to find out. That is one of the easy solutions. The other thing is that you have to know uh, bitwise XOR. Now, if you do bitwise XOR of two same numbers, then they cancel out each other. Okay, that's a property. You can read it online as well. So what our overall solution looks like is that you can do a bitwise XOR of all the three numbers. And in that whole scenario, what will happen is that the two numbers that will be same cancel out each other. Okay, so let's say you do a 1 bitwise operator sign is this. So you do this operation that 1 XOR 2 XOR 2. So these two elements get cancelled out and the answer will be 1. So answer will be here. Okay, so that's the much simpler approach instead of like doing for loop for all of them and checking out which one is unique. That one is a very simple approach. So let us move on to the code part now. I'll just show you the code part. And don't worry, all the codes will be in the description of this particular video. So as you can see, what we have done is that we have iterated over all the three numbers. We have taken the input of A, B, C and find out A XOR B XOR C. And whatever is the answer of this operation will be the output. Pretty much simple. Okay, the next one is not unique Latin squares. So as you can see here, we have a Latin square of 3 by 3 grid. So you are given different squares of 3 by 3 grid. Now you are given that it is made up of A, B, and C, such that in each row, letter A, B, and C appears only once, and in each column, A, B, and C appears only once. So in each row and each column, A, B, C should appears should only once. You are given a Latin square, as you can see here in the input, but one of the letters was replaced by question mark. So you are given a 3 by 3 square, but one of it is replaced by a question mark. You just have to find out what character you have to place at the question mark A, B, or C. Now, because it's a Latin square, it is already given to you. It's pretty much simple that you just have to find out where that particular question mark is. And you just have to also ensure that whatever or wherever this question mark is, that particular row or that particular column should have A, B, and C occurs once. And they all should occur. So whatever is the position of question mark, take that row, find out that whether. So let's take an example of this only. You take this, you find out that the question mark is here. So you just find out that this is C question mark and B. So find out all the elements in the row where the question mark is. And see that we have a C, we have a B, so only A is left. So answer is there. So pretty much simple. Find out the location of question mark and then find out, take that row, check that whether that row has A, it has B, it has C, whatever is missing, print out the answer. Pretty much simple. Let's move on to the code part now. So what we have done is that we have taken the input of the particular square, find out where the question mark is, store that particular row. Wherever is that particular question mark, store that row. Then find out in that particular row whether it has A. If it doesn't have A, print out A. Whether it has B, if it doesn't have B, print out B. Or else if it has A and B, it should be C. Okay, pretty much simple that because it's a Latin square, it should have A and B and C in the same row. So find out that row where the question mark is. And in that row, check out whether A, B, or C, which one is missing, print out that. Okay, pretty much simple. Let's go to the C question. Now, can I square? So Callan has n buckets. The ith bucket contains ei votes of square of length 1. So you have different buckets. Each bucket have different squares of length 1. Can Callan build a square using all the given squares? Can Callan build a square using all the given squares? Okay. So you are given wooden squares of length 1. Okay. Let's draw it out. So different squares of length 1. Let's say like this. So can I make a bigger square using these smaller squares of like size 1? It's also pretty much simple. To make a square, the length and width should be same. So you already know that if to be a square, it should also be a square. Like the number of small squares of size 1 we have should also be a square. So let's say I can make a square of size 1 using only one square. I can make a bigger square of size 2 using four squares. As you can see, 1, 2, 3, 4. I can make more bigger square. So how many squares is that? 9. So this is a square of 1. This is a square of 2, square of 3, square of 4, and so on. So you just have to find out the sum of all the woods, wooden squares of length 1 that you have. You just have to find out the sum of all of the elements in the input and check that the sum should be a perfect square. So you can use the sqrt function to check that whether it is a square or not, square root. Like, because if it's the total, let's say 16, 16 is a square root of 4. And because it's square root of 4, which means that I can form a bigger square of length 4 by 4. Okay, pretty much simple. So nothing much complicated here itself as well. Let me know the code part now. So we have done the summation of all the elements. Check that whether, find out the square root of the total sum and check that the square root is valid. Okay, because the square root function can also give you in, you can say 3.5, like whatever the actual square root, but you just have to also ensure that it's a perfect square root. We don't want a like square root in points. If it's a perfect square root, then only we print out yes that we can form that particular bigger square, or else we can't. So that's the logic and code part for all the three problems. If you still have any doubts, you can mention it in the comment box. That's about the video. I will see you in the next one. Till keep coding and bye.